Hello world, it's Angela. I'm here in sunny Minneapolis, and I'm here for the eyeo 2014 conference. So this is a really interesting gathering of, I think, 700 people, and from what I gather, it's all about visualizing. And data visualization is a big part of that. This is my second year here, and I think it's a bigger part this year than last year by all the lightning talks and the themes of a lot of people are talking about. So, it's really interesting to me, both professionally and just general interest. And I wanted to share a couple of the bigger takeaways I've had so far, just really quickly in this video. There's a lot going on, a lot to take in, trying to take notes and stuff. But I'll just share a few gems I've heard so far. So the keynote speaker last night to open things up was this guy Frieder Nake, a German guy who I hadn't heard of before, but he was making computer graphics in 1963 before computers had screens. It's just really nuts. He was making computer art actually, and he just had a great, funny talk, but he left me with something that I really resonated with me, which he said is a quote from someone else, that it's so frustrating not to see what you're doing. And that quote was originally someone who was programming on a computer that didn't have a screen. They just had to, they had little knobs and things to literally change ones to zeros. But I think it still holds true today. When I'm working, trying to think through algorithms in my head, and I can try to calculate and predict what the computer's going to do, but whenever I'm able to kind of make a visualization that shows what the computer is doing, I feel so much better about the process, the results. It really augments my abilities. So it was great to hear someone who's been thinking about this for 50 years leave that as his most important point for a crowd of people that are trying to do visualization. So it seemed like Mike Bostock was almost answering him, because his talk was all about how to visualize algorithms, or rather his practice of visualizing algorithms, both for fun and his own understanding, to show how things work and to compare algorithms. So he's got several really beautiful blocks showing how different sorting algorithms work, how some sampling algorithms work, and some maze generation stuff. And it's really inspiring to kind of see someone go through this process to really be able to see how the computer is doing things. And that can really help. Maybe you can't look at this and be like, oh, I understand quicksort now. But if you're trying to understand quicksort, I think this does help a lot. Another speaker was Nicholas Felton, who's spoken apparently every year, and he does these annual reports where he visualizes data that he collects about himself. But this year was super interesting because he decided to collect every conversation that he had. So if he said thank you to somebody as they held the door open to him, he would write that down, and then he would write down what all his conversations with his girlfriend, people he worked with, phone. And of course he had all his texts and emails already available as text data, and then he went through and tried to make it computable and visualizable, and he hasn't put that up anywhere yet, I think, but it was just super fascinating because he even had this slide where he had a checkbox of all the things that he collects and all the things that the government collects, and probably the only thing that NSA doesn't have is personal one-on-one conversations that aren't taking place on a digital device. So it was really interesting to see how he looked at himself through that data and what he could figure out, and it was pretty powerful, just in the ways that he could see, how patterns about his own life, things like sleep patterns, or who he talks to, who's important to him, who's not. And to think that the government can do that on everyone, it's kind of scary. So another thing kind of on the technical side that was interesting is he talked about using Alchemy API, which I hadn't heard of, but basically you can use this to get some structured data out of unstructured things. So if you just have a string of text like San Francisco, it will tell you, hey, that's a place, a city name. So that's something interesting to try to pull, for all kinds of reasons. So I'll be playing around with that. Another speaker, what was his name? Adam Harvey, is doing this really interesting art where, these are ways to basically screw up facial recognition algorithms, things that can detect faces, not just recognize, but like notice that there's a face. So as cameras become prevalent, Facebook, everyone, pictures of you are now online forever, and if you ever need to get around without people knowing that you're getting around, and he was using celebrities and paparazzi as kind of the example currently, but it's really interesting, and he really brought up this topic of fashion, because fashion's a $300-something billion industry, and apparently like surveillance technologies like in the tens of billions, but really the analogy is that fashion changes so constantly. We're always changing reaction to the latest trends, and if you think about facial recognition algorithms or facial detection algorithms as a trend, right? People discover, we can get better detection now using this technique. Well, there's always going to be something you can do to screw that technique up, right? The computer's looking for something, and you can show it something that will make it think it's not finding that. So you can always stay ahead of the fashion trends in the facial detection industry. So that was the kind of glimmer of hope in a pretty terrifying talk otherwise, because cameras are getting so crazy. Like the military grade cameras on a drone at 1,700 feet produce a terabyte of data a day, at 6-inch resolution, and they're sensing in more than just light we can see. They're looking at infrared and thermal. You can't hide from the heat-seeking cameras. So yes, a lot of thinking about data and how we look at it, and who's looking at it, and who's looking at you, who are we looking at. There's also this Code Ed Summit, which an unconference that I really loved last year, where I just got a bunch of people that attend the conference to set their own agenda for one day, and you have hour-long blocks, and I tried to lead one on curating and collecting educational code examples, and so we talked about, there were some teachers in the room of high school and university, and people who are practitioners, and we all trying to talk about, like, because the practitioners are all self-taught in these new technologies, how we can use examples, and the challenges that the teachers face with students nowadays are just copying the examples to like get the answer. Like everyone just wants the answer. No one's trying to solve the problem. But some takeaways I got from this was in one of the sessions, one of the teachers was talking about putting contact information in the user agent when they make a scraper to go like download data of websites, and they actually, no one gets mad at them. It's not the opposite. People have reached out and said, hey, we'll give you that data, you don't have to scrape it. Speaking of teachers having trouble teaching new technologies, somebody who is trying to implement data science curriculums in LA high schools is facing the problem that she can't get the teachers to teach it because they don't understand it, and they're afraid of trying to teach technology, and there's so little time to prepare for in the next year. How can you possibly expect a teacher to master something that like professionals are spending months trying to stay on top of everything that comes out? So that's, I don't know, I mean, that's just a tough problem right now. And then while talking about teaching big data and speaking of things moving fast, we talked about big data really being just any data that's bigger than that can fit on your laptop. And so one teacher was saying, we're reaching limits of like what we can compute on our laptops, and do we need to go learn all these like crazy, or teach the kids like all these crazy tools? And my response is, I think you should use cell phones, because you can have big data on a cell phone that's normal data on a laptop, and if you need to like practice or like create an assignment where you need to compute something on a small machine, then it's nice to have a bigger machine that won't take forever to compute that, so you can verify your answers, you can iterate faster, and you can maybe even do like a distributed computing across cell phones if you really want to like get the concept of scaling through distributing going. Then there's a session on community building, which is really important to me. Running the D3 meetup and unconference, it's really cool to get to meet people who are running groups small and big. One of the organizers of this, the I/O conference, was there, but also people running like really small like designathons, or shout out to Map Time and SF, because their individual meetups are only 20 people, but they have meetups all over the world now at different cities doing the same thing. And it's really interesting to hear that there's a common denominator amongst all of them, which is that there's some kind of barrier to entry to be a part of the community. And what that means is, like, for Map Time, you have to like do a certain amount of work, like get a venue and potentially a sponsor, and like some administrative work to like prove that you're gonna follow through, and then they'll like bring you into the Map Time fold. Or like at the D3 Unconference, we asked people to fill out, like, create a block, which is something that you would do if you program D3 a lot, and that was kind of proof that you're part of the community, and it kept the quality of the attendance, like, everyone who attended was super focused and into advancing the community. Finally, I just wanted to bring up that an interesting thing, diversity was talked about, which is something I think I've personally always been interested in, but kind of hadn't even really thought too much about in the context of like running an organization, like a meetup group. But people are trying to actively pursue diversity, either content-wise and like bring in different perspectives, but also like gender and race, and because in tech, people making stuff with computers were mostly white males, honestly, and for whatever reason. So trying to get people, some diversity into the overall tech ecosystem, and including in the meetups that we're doing, is a tough challenge. And someone mentioned a quote, and I wrote it down here, that I really liked, is that if I can't see it, I can't be it, right? So even though I can't really identify with what it's like to be a minority, that really rings true with me, that like if I couldn't see myself as doing something because no one that's like me is doing it, like that would be a hindrance, right? And so I want to close out with a choice quote from my favorite rapper. This generation, I'ma represent a generation led by a black president. Now how's that for change? Who knew that can change? I don't even look at the flag the same. Yeah. So it's really important to see things for yourself. All right. Catch y'all later.